My great students, I welcome you once again to another concept, that is even function. We've already looked at onto functions, one-to-one function, many-to-one function. This time we are going to look at even function. So we are looking at one of the types of functions we previously mentioned. All right, good. So I will want each and everyone to stay calm and watch carefully, observe whatever bothers your mind. After the lesson, you can go to the comment section and add your submission or ask any question, and we are ready to help you out. Okay, now in this lesson we are saying that even function is a function where the graph, or when the graph of that function is symmetrical. Okay, when the graph of that function is symmetrical with respect to the y-axis, then we say that that function is what? Even function. When do we even see a function is symmetrical? Okay, respect to or above y-axis. So when we say it is symmetrical, what we are trying to say is that, now let's look at the graph of the even function. This is a graph of what? Even function. Example, we have y is equal to x squared. Okay, it is one of the examples of even function. Okay, good. So looking at this diagram, you realize that this is what? The curve. This is a curve. So you realize that this is what? Parabola. All right, good. If it is symmetrical, it means that if I fold it along the y-axis, then it is going to be one part is going to be folded on the other part, or is going to reflect on the other part. Have you gotten that? So looking at it, this is what? My y-axis. This is the y-axis. So in case if I fold this along the y-axis, you realize that this is half and this is half. The half will fit exactly on the other half. It will divide it into two equal parts. When we say it is symmetrical, when I divide it along the y-axis, you realize that it will divide it into two equal parts. So if I should fold it so that the other half can what? Fit onto the other half, then we say that graph is what? Symmetrical about what? The y-axis. If we see that it is symmetrical about x-axis, that means if I also fold it along the y-axis into two equal parts, one part should be able to fit when I fold it onto the other part. All right, that is what we are talking about. So we can talk of some examples of even function. We can list some of them. So we have x squared. Can be one example. We can have the absolute value function, example like this. Okay, we can have x exponent 4. So all the x exponent what? Even numbers. When you realize that the exponents are all even, they are all part. Okay, so we can have 6, we can have 8, and the likes. Okay, we can also have trig functions where we can have cos what? X, and its what? Inverse. Cos x and its inverse. They are all what? Examples of even functions. All right, so that is about even functions. Now we are going to look at how algebraically we can test or show that a function is what? An even function. A function is an even function. So algebraically we can say that a function is what? Even if, okay, a function is even if, so a function is even if this f at x is equal to is equal to f at negative x. Okay, good. So we are using this to show that a function is an even. So a function can only be even if f at x should be the same as what? F at negative x. So let's take our first example, solve it to look at how it works. All right, okay, so let's take our first example. Good. So let's look at these two examples and see. Okay, we are going to test it using this one, whether it is even function. Okay, so the first one, we know that so let's begin with our solution. Okay, we know that the first one, f, we are saying that for a function to be even function, f at x should be equal to what? F minus x. Okay, so we are going to test the two. We know that f at x is what is given in the question. Okay, so we are going to prove whether after substituting negative x for x in the function, we are going to get the same function. That is what it means. It means that when you substitute negative x into the function, or for x in the function, you must get the same function or the entire function. All right, great. So we know that the function is giving us 2x squared minus 1. Let's see if it will be equal to this. So here what it means is that wherever I see x in the function, I should put negative x there. So it is going to be 2 open bracket negative x. This, I'm putting this in place of x, and they said I should square it, so I will square it, then minus 1. Now I know that when you square this, it will give me what? Positive, because the negative, the square will affect this, it will affect the negative, so all will go positive. If that is the case, then 2 times x will give me 2x squared minus 1. So you realize that we still have the function. So this is the same as the since this is the same as that, and we can conclude that the function is what? Even. Okay, so you can just say therefore, since this function is equal to this function, then f at x is equal to 2x squared minus 1 is an even function. Great. All right, now let's test for the second example, the example 2, and see whether it is even or it is not. Okay, so we know that for a function to be even, then f at x should be equal to f at negative x. So this is the entire function. I'm going to write it x plus 2. Let's see if it will be equal to, when I substitute negative x for x in the function. So I have my 3 here. So it means that whenever I see the x here, I'm going to put negative 3 there. Negative x, sorry. All right. So I'll just put negative x here. Then plus my 2. Okay. Now we know that if this is negative, then when I multiply this by this, I'm going to get negative 3x plus 2. Now let's compare whether they are the same. Could you realize that the first one here is positive, but here is negative? That changes everything. It means that it is not the same. For that matter, we can say this function is what? An even function. You can therefore that since this is not equal to this, then f at x equals 3x plus 2 is not an even function. Great. So you see that is very, very easy. Okay, so when we ask you to show or test whether a function is an even, you can use this format and get your answer right. Let's see if we can try and solve another example on this. All right, great. But before we solve another example, let's look at this. Do you know that we can also use numbers to test? When it is given to you, when a function is given to you, we can use numbers to test, okay, whether it is even function. So let's go back to the first example that we solved. So let me cancel this. Okay, so in the first example, it was given as what? F at x is equal to 2x squared minus 1. So when we tested for this one, we realized that it was what? An even function, because at the end of the day, we saw that the f at x was equal to the f at negative x. This was the first example. Okay, and I'm saying that we can also use numbers to test. Okay, by representing x, we can represent x by what? Numbers. So maybe let me choose a number. Let's say 2. So I can say that when x is equal to 2, okay, so what this means is that I'm going to use this 2 to test. I'm going to substitute the 2 for x in a function and substitute negative 2, okay, for this in the same function. So this is what it is going to be. It means that I'm going to test with 2 should be the same as when I test with negative 2. This is what is going to be done. Okay, so let me substitute into the function. It means that wherever I see x, I will write 2 here. Okay, so I'll write 2, open bracket, 2 squared minus 1. That's the left side here, which should be equal to the right side. Then I will have 2, I'll open bracket, negative 2 squared minus 1. So let's continue. Okay, all right, now we know that 2 squared gives me what? 4. Okay, so I have my 4 minus 1 is equal to, and we know that negative 2 squared will also give you what? 4, positive 4, because the square will cater for the negative. Okay, all right, minus 1. But please remember this. Note that negative 2 squared is not the same as negative, or in bracket, squared. Note this. It's very, very, most at times students make these mistakes. They think that when they see this is the same as this. No, what this means is that negative is somewhere, okay, and my 2 squared is also somewhere. So the negative is multiplying this, which we know that it's supposed to be negative 1 times this. So this one will give you negative 4. But this one, because everything is in the bracket, then the square will affect this. It will affect the negative, which will what? Nourish the negative and make it what? Positive. All right, good. So take note of these basic ideas. All right, great. Now let's do the calculation. We know that this times this gives me 8 minus 1, which is equal to 8 minus 1. We know that it gives me the same as what? 7. So you see, even when we use a number to test, we have gotten the same. This suggests that the function is what? Even. Now let's try the same 2 for what? The question 2. So for the question 2, we know that it was given as f at x is equal to 3x plus 2. So I'm going to use the same 2, which means my f at 2 should be equal to my f at negative 2. Okay, so I'm going to substitute these values here. Now I'm going to get 3 multiplying 2 plus 2, which is equal to 3 multiplying negative 2 plus 2. Now 3 times 2 gives me what? 6 plus my 2, which gives me 3 times negative 2 gives me what? Negative 6 plus my 2. Let me add here and add here. This plus this gives me 8, which should be negative 2 plus this gives me negative 4. So you realize that they are not the same. Have you gotten that? So we can't say that this is the same as this. So when the question is given to you, you can do it the first how we solve it, or you can use numbers to test, and all of them work. All right. Okay, now we shall look at, because of our time, we shall look at another example in our next videos. So for now, this is all about what? How to show whether a function is what? Even. All right. So this brings us to the end of today's lesson. We shall look out for a lot of examples or more examples. So my dear students, my great learners, I will encourage each and everyone to take your time, read more on these functions. All right, great. You can go to the comment section. If you have any question, you can submit it there. I will go through your question and help you out. So this is Maths TV. I'm your facilitator, Evans Okai. See you next time. Thank you. Bye bye.